Alright, Sven and Ole are taking a little ice fishing trip. They're leaving from the same place at the same time, but Ole drives 20% faster than Sven, and he arrives a half hour earlier. How many hours did Sven drive? Alright, well, let's turn these words into mathematical equations. So, um, first thing, this is all about distance, rate, and time. And we're going to assume that their rate is constant. Okay, that both Sven and Ole are driving at a constant speed. They aren't like starting out at 10 miles an hour and gradually getting up to 50 miles an hour over the course of their. They're driving at a constant speed, or at least maybe working with their average speed. Okay, um, so distance equals rate times time. Okay, we're going to assume that holds. And the first thing it says is that Ole drives 20% faster than Sven. Okay, so I'm going to call RO. I'm going to call that Ole's rate. And that's equal to Sven's rate. I'm going to call that RS plus 20% of RS, right? So that would like be, well, I could write it as 20 over 100. Let's write it that way, since that's the definition of percent. So 20 over 100 times RS. Okay. Now I can rewrite this. We got essentially one RS, or I could write this as 100 over 100. So I could write this as 120 over 100 RS, or I could just go straight for 1.2 RS, okay? Or I could write that as 6/5, okay? 6/5 of RS, alright? So this, this relates Ole's speed to Sven's speed, and basically says that Ole is driving 20% faster than Sven, okay? Alright, their time. We're also given some information about their time. We're told that Ole arrives a half hour earlier than Sven. Okay, so the time that Ole drives is equal to the time that Sven drives minus 1/2. Okay, we'll just work with time in hours. So I'll just use the half. We could convert this to minutes, but a lot of times speed is given in miles per hour. Just have to make sure we watch the units, and we're not really actually given any speeds. So we'll just take the time in hours, and so I'll use a half. We also know that they're driving the same distance, right? Because they leave at the same time from the same place, and they're going to the same spot, the same fishing spot. So their distance is the same. The distance is equal to rate times time. Let me just write that. So the distance that Ole drives is equal to the distance that Sven drives. And we can just substitute. Ole's time is going to be Ole's rate times Ole's time. So this is the same as RO times RO times TO. Okay, Ole's rate times Ole's time is equal to Ole's distance, right? And Sven's rate, RS, times Sven's time, TS. Those are both going to give us the same distance, so we'll set them equal to each other. And now let's just do some substitutions, because we have we have Ole's rate in terms of Sven's rate, and we have Ole's time in terms of Sven's time. So we can substitute. For RO, we can just use this 6/5 RS. So we'll just say 6/5 RS. And then for Ole's time, we're going to substitute TS minus a half. Okay? And so now everything is in terms of RS and TS. Okay? So let's see what we can do with that. First thing I'm going to do is distribute this 6/5 RS. Okay, so I'm just going to take this whole thing and I'm going to multiply it through the parentheses. So what do I get when I do that? I get 6/5 RSTS minus, now I take 6/5 times a half, I'll get 3/5. And that's equal to RS TS. And then you can see I have a term in here. Oops, this should be RS, right? Yeah, because I'm multiplying 6/5 RS times a half. Alright, and you can see I have these terms RS TS. So I can actually combine those. And this is like 1 1/5, and this is 1, so if I subtract 1 from 1 1/5, I end up with 1/5 RS TS. So all I did was I subtracted RS TS from both sides. Doesn't change the equation, so we can do that. And then I'm going to actually add 3/5 RS to both sides as well. That'll just move this RS term over to the other side. So we get 3/5 RS. Okay. Now we have some common terms on both sides. We've got RS and RS. So if I just divide both sides by RS, the RS goes away. And then we also have a fifth on both sides. I have 1/5 here and I have 3/5 here, which is just 3 times 1/5. So I'm going to cancel the 1/5 as well, because if I divide 1/5 by 1/5, I get 1. And I've done the same thing to both sides, so it's still a valid equation. Okay, the equality still holds. And all I'm left with is TS on this side now. So this tells us that Sven's time is 3, and you know, we used hours up here, so this is in hours. So Sven's time is 3 hours, and that was what we wanted to find. How many hours did Sven drive? So our answer is 3 hours.